Welcome back on the class of soil and rock mechanics. So in the last class I have discussed about the sheet pile wall, and in sheet pile wall I have discussed cantilever sheet pile wall for different types of soil, like for cohesionless soil and for cohesive soil, and we have seen the how to compute the depth of embedment by approximate method in cohesionless soil, and after that we have seen the depth of embedment for cohesive soil. And I told you that if factor of safety is not given, so we can increase the depth of embedment by 30%, and with the help of that we have computed the depth of embedment. So today I will going to discuss another chapter, that is stability of slope. So in stability of slope we will discuss so many things like types of slope, infinite slope, finite slope. In infinite slope we will discuss what will be the factor of safety for different types of soil, like for dry soil, for cohesive soil, and when seepage is parallel to the ground slope, then what will be the factor of safety. And after that, in finite slope we will discuss the Taylor stability number, what is Taylor stability number, and with the help of Taylor stability charts how to compute the value of factor of safety in a slope. So let us start about stability of slopes. So what is slope? So slopes are for embankment, are provided in roadways, railways, earthen dam, or river draining work. So slopes are provided for the embankments, roadways, railways, earthen dam, and river draining work. So in the slope, failure of which takes place due to the following forces. So failure of slope is due to the following forces. What are the various forces? So first one is gravity force, second one is seepage force, third one is earthquake force, and the fourth one is very important, sudden drawdown in water table. So next one is erosion due to water. So these are the various forces that will be responsible for the failure of slope. So slopes, next heading is types of slopes. So there are two types of slope. First one is infinite slope, and the second one is finite slope. So infinite slopes are defined as the slope which will extend for long distance, and the finite slope which is extend for short distance. So let us take the first one is infinite slope. So if the slopes represents the boundary surface of semi infinite soil mass, if the slope represents the boundary surface of semi infinite soil mass, then properties of soil at all the similar depth, at all the similar depth below the surface will be same, then the slope is termed as infinite slope. Failure of infinite slope takes place due to the sliding, and failure surface is parallel to the ground surface. So failure of infinite slope takes place due to sliding, and failure surface is parallel to ground slope. So example of infinite slope is mountain slope. So let us take how to compute the value of factor of safety, because factor of safety is important for the design of infinite and finite slope. So stability analysis of infinite slope. How do we compute the value of factor of safety? So let us take infinite slope. This is slope, and it makes an angle of slope angle beta with the horizontal. So if I take an element, let us take A, B, C and D, and this depth is Z. So AB and CD. So let us assume, let AB represents infinite slope having slope angle of beta with the horizontal. Failure of which takes place along the critical plane CD. It means parallel to ground slope, and is at the depth of Z from the surface. So let us assume AB is the infinite slope having an angle of slope angle beta with the horizontal, and CD is the failure of which takes place along the parallel to this slope at a depth of Z from the ground surface. So we can compute, if let us assume this width is B, so what is the value of this? Value is B cos beta. And this is weight. So the weight, there are two components of this weight. One is normal stress and another one is tangential stress tau. So I am interested to compute the value of normal stress and tangential stress. So area of ABCD is how much? Area of ABCD is Z into B cos beta. So Z into B cos beta into Z. So it is coming BZ cos beta. Similarly, volume of ABCD is how much? BZ cos beta, and for the unit length. So weight of ABCD is how much? Unit weight of this material. So gamma is the unit weight into volume. Volume is BZ cos beta. So it is coming gamma BZ cos beta. So vertical stress sigma Z is nothing but weight upon area. So weight we have computed gamma BZ cos beta, and area we have computed how much? B into 1. So it is coming gamma Z cos beta. Vertical stress. Similarly, vertical stress, this one is sigma V. So vertical stress, once we have computed, normal stress on the critical plane is nothing but the component sigma n is nothing but sigma Z cos beta. So normal stress, I have told you, this is normal stress, this angle is beta, so this is sigma n gamma Z into cos beta. So the normal stress is nothing but gamma Z cos square beta. Similarly, tangential stress on the critical plane tau is sigma Z sin beta. So sigma Z is gamma Z cos beta into sin beta is the tangential stress we have computed. So we have computed the normal stress acting on this force on the element of infinite slope, and tangential stress we have computed. So note. So these two formulas will be used for computing the factor of safety. So the tangential is also termed as shear stress that induces failure along critical plane CD by sliding, which is being resisted by shear strength of soil. So factor of safety is nothing but shear strength of soil divided by shear stress on that plane. Factor of safety can be computed by shear strength of soil by shear strength on that plane. So FOS can be written as tau F by shear strength of soil. So I have denoted shear strength of soil is tau F and shear stress on that plane is tau. So let us take first case first, not cohesionless soil, and part first is dry or moist slope. So according to Mohr-Coulomb equation, we know shear strength is nothing but C plus sigma n tan phi, where C is the cohesion of soil, sigma n is the normal stress, and phi is the angle of internal friction. So we have seen the Mohr-Coulomb envelope. So this is the Mohr-Coulomb envelope. This is shear strength and this is normal stress. So we have seen for cohesive soil, it's coming like that. So this intercept is cohesion and the slope is angle of internal friction, and this is Mohr envelope or modified Mohr-Coulomb's equation we have seen. So this is the modified Mohr-Coulomb's equation. Sigma n dash, this value is effective cohesion and this value is effective angle of internal friction. So we have seen in the shear strength of soil how it will come, and Mohr envelope, this is also modified Mohr envelope. So for this case I have assumed cohesionless soil. So for cohesionless soil, cohesion is equal to 0. So shear strength is converted to sigma n into tan phi, and sigma n we have computed how much, derived gamma z cos square beta into tan phi. So tau f we have computed how much, sigma, where gamma is the unit weight of soil, z is the depth, beta is the slope angle with the horizontal, and phi is the angle of internal friction of soil. So factor of safety for cohesionless soil is nothing but tau f by tau, and tau f is sigma n tan phi divided by, and tau expression of shear stress we have computed, it is coming gamma z cos beta into sin beta. So factor of safety for the cohesionless soil is sigma n we have computed, gamma z cos square beta into tan phi divided by gamma z cos beta into sin beta. So gamma z cancel out. So factor of safety is coming tan phi by tan beta. Very, very important for, but this factor of safety is valid for cohesionless soil. So for cohesionless soil, factor of safety is coming tan phi by tan beta. So if factor of safety is greater than 1, means phi greater than beta, slope is, then such type of condition is called slope is stable. When factor of safety is greater than 1, so tan phi is greater than tan beta, so beta phi is greater than beta. If factor of safety is less than 1, means phi is less than beta, so slope is unstable. Slope is unstable. And if factor of safety is equal to 1, means phi is exactly equal to the slope angle. So in such case our slope is in critical condition. So slope is critical. So let us understand with the help of diagram, graph. So this is tau axis and this one is sigma n axis. So for cohesionless soil we have seen the more Coulomb envelope. So when cohesion is 0 means this is more Coulomb envelope. So this is more envelope, and this slope of this is angle of internal friction, or this angle is phi. So when beta is for stable slope, what is the condition for the stable slope? Factor of safety should be greater than 1, and factor of safety should be greater than 1 in which condition? When slope angle is less than angle of internal friction. So if I draw this, so we have seen if this angle is beta and greater than phi, so in this condition slope is unstable. Similarly, when beta is less than phi, this condition in which beta is less than phi, so in this condition slope is stable. So we have seen with the help of more Coulomb equation. So we have seen the three cases in which we have seen whether the slope is unstable, critical condition or stable condition. So when the slope is in critical condition, so this is beta is equal to phi, and when slope is unstable, so angle of slope is exceed the value of angle of internal friction, and when slope angle is less than angle of internal friction, so slope is stable. So let us take some points. If beta is less than phi, slope is stable because for any given value of normal stress, shear stress is less than shear strength of the soil. So if beta is less than phi, so slope is stable because for any given value of normal stress, shear stress is less than the shear strength of soil. Similarly, if beta is greater than phi, so slope is unstable because for any given value of normal stress, shear stress tau is more than shear strength tau. So for we have seen the shear stress tau is gamma z cos beta into sin beta, and shear strength of soil is gamma z cos square beta into tan phi. So when beta is greater than phi, so slope is stable, because why? Normal stress for any given value of normal stress, shear stress is more than the shear strength of concrete. So factor of safety is the ratio of tau f upon tau. So this value is exceed. So this value, factor of safety, is less than unity. That's why it is unstable slope. So dear learner, today I have discussed about the infinite slope, and in infinite slope I have taken a section and we have computed the value of normal stress and tangential stress or shear stress acting on that section, and we have seen the expression of normal stress, that is gamma z cos square beta, and for the tangential stress it is coming gamma z cos beta sin beta. And with the help of this normal stress and shear stress, we have derived the expression of factor of safety for cohesionless soil, and we have seen the factor of safety is coming for cohesionless soil is tan phi by tan beta, where phi is the angle of internal friction and beta is the slope angle. And after that we have analyzed whether the factor of safety, in which condition our slope is stable, in which condition our slope is critical, and in which condition our slope will fail. So we have seen with the help of Mohr-Coulomb equation, we know the shear strength of soil is C plus sigma and tan phi. So we are analyzing cohesionless soil, so the value of cohesion is 0, so our shear strength is turns to sigma and tan phi, and our shear stress we have already derived. Shear stress of soil is gamma z cos beta sin beta. So in the first case I told you that when phi is greater than beta or factor of safety is greater than 1, then in that case our slope is stable. And the second case I told you that when phi is exactly equal to the beta or factor of safety is equal to unity, in that case our slope is critical condition. And the third case I told you when phi is less than beta, means our slope is unstable. So in coming class I will discuss second case when our soil has cohesion. For cohesive soil we will see the how the factor of safety will change with the cohesion, unit weight and phi and beta. And after that third case I will analyze when our seepage surface is parallel to the ground surface, then what will be the factor of safety. For more updates you can also visit my civil engineering blog talk2rashid.blogspot.com. So take care of your health and happy learning.